Hello friends, welcome to Veda Gate Academy. So myself Sivaram, I am going to teach control system subject. I completed my MTech from IIT Bombay. I am having some 10 years experience in gate as well as engineering services in order to handle this subject. So today before going to see, I would like to ask one interesting question which was asked in my interview during my IIT Bombay Systems and Control Engineering specialization. So there is a panel of 4 members are there, and before appearing or before going to start the technical session, what they are asking is, the first question what they are asking is, what you have learned from this subject, control system subject. So the answer I have started in this manner. So before going to even answer that question, even I would like to pose the same question to you. Why we are studying this subject of control systems? Without learning that subject, okay, without understanding not only this subject, without understanding why we are studying any particular concept or any subject, we cannot able to enjoy that subject. Okay, so first we will try to clear with why we are studying this control system subject, and later you can able to feel, okay, you can able to feel or understand the different topics which are there in this particular subject. Now there is a simple answer. Some of the students may say that, okay, in order to get, because we are appearing for the gate exam, and in order to get the weightage, whatever the weightage that is there in the subject of gate, I am going to score if I prepare this subject. This is a very simple answer, right? Am I right? So the students, they are saying that simply in order to get some 9 to 10 marks. By the way, the weightage of this subject in the gate exam is on an average 10% of the total weightage you are going to get only from this subject, and this is one of the very important, easy as well as interesting subject for our either EC or electrical or instrumentation students. Now if you are taking the answer, simple answer, if you are saying in order to get 9 to 10 marks in the gate exam, that is a very simple wrong answer, right? Now I will try to tell you why we are studying this subject. The answer has to be in this manner. So the reason why we are studying control system is in order to analyze the performance of any practical system. That practical system may be a fan, or maybe a tube light, or maybe an air conditioner. If you want to analyze the performance of any practical system that is existed in nature, we need to understand 3 factors from that particular system. Those 3 factors are called as performance factors of a given system. Performance factors of a given system. So what are those 3 performance factors which are used to decide the performance of any practical system? Those 3 performance factors are, one is stability, second one is speed, and third one is accuracy. First one is what? Stability. Second one is what? Speed. And third one is what? Accuracy. So if you can able to determine the performance of any system with the help of these 3 factors, then I can able to understand whether my system is working very well or not for the corresponding given input. So here these 3 factors are called stability, speed, and accuracy are called as performance factors. That means if I am giving some system to you, you need to understand yourself whether the system is stable or unstable, whether the system is faster or slower with respect to the given input, and whether the system is accurate or inaccurate with respect to the reference input. If you can able to understand how to determine the stability, speed, and accuracy, then it is very easy to design that particular system. Let me explain some more information regarding more into what is the exact meaning of these things. So in order to understand, let me take a simple example. Okay, assume you are a control engineer. Okay, you have done your PhD or MTech in the control system specialization. Imagine you are a very well known control engineer. Now my requirement is, I am a customer to you. I require a fan, a simple ceiling fan I require, but my requirement is, for this fan, you have to design this fan in such a way that the fan has to rotate with a speed of 1000 RPM. What my dear friends, my fan has to rotate with a speed of 1000 RPM, and my second requirement in this case is, this speed of 1000 RPM has to reach within 20 seconds after I switch on the supply. Okay, are you following what I am conveying? That means immediately if I switch on the supply, immediately my fan cannot able to rotate with 1000 RPM. It will take some time. My second requirement is, the fan has to reach this 1000 RPM within 20 seconds after I switch on the supply. Okay, so you may have a doubt that I have a regulator, with the help of regulator I can able to control the speed, but I don't want regulator. My customer, I am a customer to you, and my requirement is, you have to design a fan without any regulator. I will directly connect the fan terminals to the supply terminals, and immediately if I switch on the supply, my fan has to rotate with a speed of 1000 RPM, and it has to take how much time to reach that 1000 RPM? It has to take only 20 seconds. Okay, in our control system terminology, whatever this statement which I have given is called as control objective. So what is this one, friends? This is called as control objective. So what is the control objective here? The control objective here is we have to design a fan in such a way that the fan has to rotate with a speed of 1000 rpm and it has to take 20 seconds within after I switch on the supply. Now imagine if you are a control engineer and if I am giving this task to you, what you will do? So can I directly go to the hardware market and purchase the different components which are presented and I will assemble those components in order to get this requirement? If I blindly go to the market and if I purchase those components and if I shoulder those components to get a fan, I cannot able to meet this control objective. Am I correct or not? Right? So first what we have to do, any industry, not only this particular fan, if you are going to automotive industries or if you are going to chemical industries or if you are going to power systems or generation, any industry will follow some standard procedure in order to arrive to the final product. Now we will try to understand that. Okay, so if you try to see, let me take a case, let me take a fan example, again the same thing. So for suppose if you are taking a fan, what are the different components which are presented in this fan? First you have to understand that. Okay, now if you are segregate this fan different components, I will segregate into two components. One is belongs to electrical and electronics components and second one is mechanical components. Now if you are taking the components which belongs to electrical and electronics engineers, the different components obviously will have a motor. Am I correct or not? So you will have a single phase induction motor. I will write a short notation IM. Generally we are using a capacitor start capacitor run induction motor, followed by to maintain the time to reach the 1000 rpm within 20 seconds, I require a small IC which consists of some resistor and capacitor in simple terms. Okay, so don't go in depth into this. Now if you are taking a mechanical components, the different mechanical components which are presented in this one, obviously you can physically visible from our eyes, right? So one is you will have a wings, or in simple terms we can call it as blades, and you will have some bearings, and followed by you will have some nuts and bolts to fix this one, nuts and bolts. Now what I will do is I will give the same control objective to these mechanical engineers as well as electrical engineers. And what mechanical engineers has to do, the mechanical engineers always keep in mind that they have to design these components, okay, wings, blades, bearings, nuts and bolts in such a way that these components can able to withstand maximum speed of 1000 rpm. At least they has to withstand a speed of 1000 rpm. So always the mechanical engineers will keep in mind that I have to design my wings, bearings, nuts and bolts in such a way that it has to withstand, all these are to withstand a speed of 1000 rpm. Whereas our electrical and electronic engineers, they has to keep in mind that they have to design the single phase induction motor in such a way that it has to rotate with a speed of 1000 rpm, and with the help of the proper values or parameters of R and C, I have to design a ICR circuit in such a way that my fan has to rotate with a speed of 1000 within 20 seconds after I switch on the supply. Now imagine my mechanical engineers are very perfect in their design and they have designed very perfectly these wings, bolts and nuts in such a way that they can able to withstand 1000 rpm. Now come to our electrical engineers, what will happen, we'll see. Now let us assume I am a very bad control engineer, I don't know how to design my single phase induction motor and all those things. Let me take different cases. I have majorly single phase induction motor, some resistors and capacitor values. I have blindly taken the values of these motor parameters, resistance value and capacitance in such a way that in the first case what happened is, okay, I have designed in the first case in such a way that if I blindly choose the parameters of motor, okay, and if I with the help of those parameters of the motor I have designed, assume that I have finally designed my fan. Okay, I have finally designed my fan, and if I switch on the supply with the help of tachometer, if I try to identify the speed, instead of reaching 1000, what will happen is my fan is rotating with a speed of 2000 rpm. For suppose imagine if I design with this single phase induction motor the entire fan, then what will happen, guys? Then what will happen? My mechanical engineers has designed all those components which can able to withstand a speed of 1000. But electrical engineers, they have designed this motor which can able to withstand a speed of, or which can able to rotate with a speed of 2000. Can I say my bolts and nuts can able to withstand this 2000? No. Such kind of situation of any system is called as unstable system. we can call it as unstable system. So the first and foremost important thing as a control engineer, what we have to do is always we have to keep in mind, that my system should be stable. If the system is stable, then only we have to think about or bother about the remaining two performance factors called speed and accuracy. Without my system is stable, there is no point of discussing about speed and accuracy. So always we have to keep in mind that my system has to be stable. Always we have to design the system to be stable. Now let me take a second case. So I obviously with those parameters of motor I cannot able to reach the stable system, right? Now what I will do is I will somehow change the parameters of motor, and finally, okay, for those with those values I have designed a fan. In that case too, exactly my speed of the fan I reach to 1000 rpm. Okay, the speed of the fan has to reach to 1000, but instead of taking 20 seconds, it is taking 2 minutes of time to reach this 1000. Let me pose the same questions. Now can you tell me, is it stable system, guys? Yes, it is stable, because all the mechanical components can able to withstand this 1000 rpm. So I have designed my system as stable system, right? It is good. So my system is stable, but is it a faster system or slower system, guys? Obviously, with respect to the control objective what I have mentioned, my system is not faster system. Why? Because I require my fan has to rotate 1000 within 20 seconds, but it is taking 2 minutes of time. So we can say my system is very slower system with respect to the control objective what I have mentioned. Let me again retune the parameters of R and C. In such a way that in case 3, let me take case 3 where I got the speed of the fan. Let me change all the parameters in such a way that for a particular parameters my speed of the fan has to reach 1000 rpm, 950 rpm now in this case, and it is taking only 5 seconds of time to reach this 950 rpm. Now I will ask the same questions, guys. Please tell me, is it stable or unstable system? Yes, it is stable, because even the wings can able to withstand. If they are designed for 1000, they can even withstand for 950. So we can say my system is stable. Yes. And the second one is, can I say, is it faster system or slower system? With respect to 1000 rpm, I require 20 seconds. But with respect to 950, it is taking only 5 seconds. So I can say my system is very faster system. But can I say, is it accurate or inaccurate, guys? Obviously, it is inaccurate. Why it is inaccurate? Because I have to design my fan has to rotate exactly 1000. But it is taking how much maximum speed, guys? 950 rpm. So there is a deviation between the reference input of the fan and actual output of the fan. How much difference is there? 50 rpm. So we can say my system is inaccurate system. Are you following what I am saying, guys? So my system is inaccurate system. So whereas if you take a second case too, can I say, is it accurate or inaccurate? Of course it is accurate. Why? Because my fan is reaching exactly 1000 rpm. So we can say it is accurate system. It is what? Accurate system. So this is the meaning of analysis. So always we have to tune the parameters, okay? Parameters of motor, parameter or values of resistor and capacitor, and in such a way that finally I need to arrive towards the required control objective. What is the meaning of required control objective? I have to fine tune these parameter values in such a way that my fan has to exactly rotate with a speed of 1000 rpm, and exactly it has to reach this 1000 rpm within 20 seconds. In that case only I can say my system is stable as well as faster system. I can say it is faster as well as it is accurate in the nature, accurate with respect to the control objective. Are you following what I am conveying, guys? So this is the exact meaning of analysis of any system. So always we have to keep in mind that. So why we are studying control system in a single statement, guys? So in a single statement, why we are studying control system is to analyze the performance of a given system. And my dear friends, what are the performance factors to analyze any system? One is stability, second one is speed, and third one is accuracy. Okay, third one is accuracy. So this is about the brief idea why we are studying control system. Now how we can able to correlate this analysis to our syllabus, whatever we are going to learn. So if you quickly see the syllabus of the GATE exam, okay, so if you see the syllabus of the GATE exam, let me take syllabus, right. So now if you quickly see the syllabus, first one we are going to study about the transfer function, we are going to study about the transfer function, as well as the other one is we are going to study about block diagrams and signal flow graphs. We are going to study about, this is the first topic. And the second topic what we are going to study in our undergraduation level is, the second one we are going to study about the stability concepts. In the stability we are going to discuss about, let me erase this. So we are going to discuss about the stability. In the stability we are going to discuss about two major topics. One is Routh-Hurwitz criteria and second one is root locus. Second one is root locus technique. And the third topic what we are studying is time response analysis. In this time response analysis we are going to study about transient response, and next one is steady state response analysis. Next one is steady state response. And the fourth one is you will have frequency domain analysis or frequency response analysis. In this you will have basically graphical tools like Bode plots are there, polar plots, and followed by you will have Nyquist plots. And after finishing of these things we are going to discuss about the tool called controllers and compensators. Controllers and compensators, followed by the last topic what you will have is state space analysis. You will have state space analysis. So these are the 6 major topics what we are going to study in our undergraduation level, and the same topics are there in the GATE exam also, right? Now how can I correlate the discussion what we have made with respect to the syllabus of this one? Let me take a one simple point here, okay, one simple point here. Generally if you are taking any industry, how they are going to start do the analysis is, first what they will do is they will do the mathematical modeling of that system. What they will do? They will do the mathematical modeling. What is the meaning of mathematical modeling, guys? The meaning of mathematical modeling is nothing but, for suppose if you are taking any practical system, it may be a electrical system or mechanical system or chemical system or any kind of system which is existed in nature, any practical system can be able to write or realized with the help of integral differential equations. That means I can able to describe any circuit or any system with the help of differential and integral equations. That means the equation which consists of both the differential and integral terms. For suppose for if you are taking a simple RL circuit, if you are taking a simple RL circuit, how can we, let us assume this is my input to the system Vi of t, and assume the objective here is we need to measure the voltage across the inductor, that is my output. Okay, let us assume this is having a resistance R and inductance L. Now if you want to design this particular, or if you want to describe this system mathematically, I will write simple differential equation. I will write KVL around this particular circuit, right? So if I am assuming the current through this circuit is I of t, if you apply KVL around this one, I can able to describe this electrical network in the form of mathematical modeling, that is nothing but differential equation. So what is the describing differential equation? If I write KVL around this one, Vi of t will be equal to R into I of t plus L into di of t by dt. So now can you tell me what is the order of the differential equation in terms of current, guys? Here the order of this differential equation is first order. It is a first order differential equation. That is the meaning of mathematical modeling. Okay, so let me erase this. So this is not related to our topic, right? Let me come back here. If you are taking any industry, first what they will do is they will consider some system. What they will do? They will consider the system and they will do the mathematical modeling of that system. After finishing of mathematical modeling, what they will do is they are going to write those describing differential equations in a computer software. Okay, so what they will do, they are going to write this in a computer software. Generally most of, if you are taking automotive companies or any industries, they are preferably use MATLAB and Simulink. They are going to preferably use MATLAB and Simulink. This is the software majorly our electrical and electronic engineering students which they are going to use to analyze the performance. Now what they will do, they are going to give some input. For each and every input the system will produce a corresponding output, and by seeing this output what they will do, they are going to do start the analysis. So because I cannot able to randomly choose the values of resistance, capacitors, and I cannot directly design the components. First what I will do, I will tune the parameter values. Here what are the parameter values? RC and single phase induction motor parameters. what I will do is I will tune these parameter values in such a way that I require a required output. Okay, so for a particular parameter values, if I am getting output which may not be accurate, right? So let us assume the system may be stable, it may not be accurate. Again I have to tune the parameters. In this software, what I will do is I will tune the parameter values until I am going to satisfied with my control objective. So here what is the meaning of analysis? We are going to see about the stability, we are going to see about the speed, that means whether the system is faster or slower, and we are going to see about the accuracy. These are the three things which we are going to see. Once if you satisfied with these values, then I can go with the design stage. What I will do? Then I can go with the design, and after designing this one, we are going to finally go with the production stage, and after finishing of this production, we are going to release into the market. We are going to release into the market. This is the standard procedure of designing any system. We cannot directly design the components. First we will tune the parameter values. For a particular set of parameter values, if I get a required objective, with those values I will design and produce those components, and finally assemble those components to get a required product, and after that I will release into the market. Okay, so here what I am doing, first I am considering some system, after that I am doing the mathematical modeling, and after that I am doing the analysis in a software. But for suppose if you want to write some program in a software, before writing a program you need to understand the prior knowledge about that particular program, right? So that means you require some basics. Am I correct or not? Those basics we are going to study in our engineering. So that means for suppose if I am giving some system, and after if you want to do the programming, first I need to understand what is the technique I have to use to make a comment on stability, and how to make a comment on speed, and how to make a comment on accuracy. If I know the prior theoretical knowledge, then I can easily write the program in the computer software or MATLAB and Simulink, or I can do the modeling, I can able to get the analysis, finally I can go with the design. Am I correct or not? Right? So if you see the syllabus now, if you see the syllabus, so what I am doing here is first we are going to study about the tool called transfer function. This is one of the mathematical tool which is used to represent any system practically in mathematical modeling. So whereas the block diagrams and signal flow graphs are called graphical tools to represent a given system. So the purpose of studying first unit is if you want to represent any given system mathematically or graphically, I can go with the transfer function as well as block diagrams and signal flow graphs. So this is the mathematical representation of a given system. Mathematical representation. This is graphical representation of a given system. So the system may be an electrical system, or maybe mechanical translational system, or maybe rotational system. Any system I can able to do the mathematical modeling with the help of transfer function, and I can able to design or represent graphically with the help of block diagrams and signal flow graphs. Now as I said, the first performance factor to decide the performance of any system is one is stability. In our control system, there are exactly 5 techniques which we are going to concentrate, which are majorly devoted to make a comment on stability. The first one is Router-Widge criteria, the second one is root locus technique, and the third one is Bode, Polar, and fifth one is Nyquist. I am not saying these are only dedicated to make a comment on stability. Majority of our discussion, with respect to either Router-Widge or root locus or Bode, Polar, and Nyquist are majorly used to make a comment on stability. That doesn't mean that they are not going to use to make a comment on speed and accuracy, but majorly we are going to make a use these techniques to make a comment on stability. Now if you go with the time response analysis, in network theory also you have studied about transient and steady state analysis. Here the purpose of this transient analysis in any system is to make a comment on whether the system is faster or slower. So the speed of any system will be obtained by seeing the transient response of any system, whereas with the help of steady state response I can able to make a comment on the accuracy of the system. That means the entire third unit, once if you can able to do the time response analysis of that system, I can able to make a comment on speed and accuracy. Now if you see, the fourth one is also make a comment on stability. Entire fourth unit as well as second unit, I can say it is used to make a comment on stability. Now here if you observe here guys, we have done the mathematical modeling in the first unit, and we have done the performance analysis in second, third, and fourth. Now what is the purpose of this controller and compensator? We have done the performance, right? The purpose of controllers and compensators is, if you are taking the same previous example, let me take the same example. I have designed these resistance, capacitance, a particular parameter values, I got this one. Now with the help of those parameters I have designed the fan and I have given to the customer. What the customer will do? The customer again will cross verify, okay, whether he is getting the required specification or not with the help of tachometer. Once if after switch on the supply, what he will do? He will use the tachometer. He will use the tachometer and he will see whether the fan is rotating with a maximum speed of 1000 or not. And after that, with some digital watch, he can identify whether that speed of the fan is reaching 1000 within 20 seconds or not. Once if he is satisfied with those, he will be happy, right? But the same customer, if he cross verify the speed and time of that fan after 6 months or 1 year, will he get the same things? No, because I can say generally we are going to say a resistor having some resistance is a time varying or time invariant. It is generally in our BTech we are going to learn it is a time invariant, but practically if you are taking any winding having some resistance, and that resistance of the winding is not a time invariant parameter, it is time varying. Why? Because generally if you see Ohm's law, simple Ohm's law, if you are taking a Ohm's law, what Ohm's law says? The Ohm's law says that the voltage across any conducting element is directly proportional to the current flowing through that element, provided the temperature of that conducting element must be constant. And based on this we have designed the resistance formula as R equal to rho L by A, where rho is resistivity, L is nothing but length of the conductor, A is nothing but area of cross section. If the temperature is constant, then the resistance of that conducting element is constant. If, because for suppose if you are taking the same fan and if you operate that fan for some 5 hours, then obviously heat will be generated, right? So if the temperature is changing, then temperature gets increases, the temperature of that system or fan gets increases. If temperature changes, then what will happen? Obviously resistance will also changes. I am saying resistance of the conducting element is time invariant provided temperature is constant. If the temperature is not constant, then the resistance of the winding is time varying parameter. If resistance of the parameter is changing, the overall behavior of the system will also changes. Because of that, if the customer cross verify after 6 months, he may not get the same 1000 rpm. Even though if he get the 1000 rpm, he may not get within 20 seconds of the time. So then what the customer will do? If the same situation is happening after 3 months, again he will come to us. Am I correct or not? He will come to the control system design engineer. Now as a control engineer, can I replace with a new fan? No. Why I cannot able to replace with a new fan? It is a loss for me. Am I correct or not? So in that case, what I will do is, in the existing fan itself, I will provide some external components in such a way that with the help of those external components, again I will meet the required specifications of the fan. Those external components which are used to improve the performance. Indirectly what I am doing, I am improving the performance of the system. Those are called as controllers and compensators. So in a simple statement, I can say the controllers and compensators are used to improve the performance factors called stability, speed and accuracy. So this is how I have explained during my interview with a single statement, and with this explanation, the single statement why we are studying control system is, if you want to analyze the performance of any practical system, I need to analyze by determining 3 performance factors: stability, speed and accuracy. And after analyzing, if you want to improve the performance factors, I am going to use the external components called controllers and compensators. So let me write this. So this is controllers and compensators. So the purpose of 5th unit is to make a comment on how to improve the performance factors. First unit, mathematical modeling. Second, third and fourth are used to make a comment on stability, speed and accuracy respectively. Whereas what is the purpose of state space? This state space analysis is also called as modern control theory. Modern control theory. Now if you see, okay, all these techniques like RH criteria, root, locus, Bode, polar and Nyquist, they are derived based on a tool called transfer function, and transfer function is having its own limitation. Let me take a simple example. If you see the limitation of transfer function, it is applicable only for linear time invariant system. But practically if you are taking the systems, most of the systems are non-linear, they are time varying, as well as they are having more than one input or more than one output. If you are taking a MIMO systems, multi-input, multi-output, or non-linear systems are time varying, in that case I cannot able to apply these 5 techniques what I have discussed. Whereas to overcome all those limitations, if I am giving some MIMO system, or if I am giving a time varying system, or if I am giving a non-linear system, if you want to do the analysis, we are going with the modern control theory called state space analysis. So this is how we can able to correlate the discussion why we are studying control system. If you can able to learn this in this manner, then definitely you can able to enjoy the subject. Are you following? Right?